Hello everyone, this is Jeremiah. In today's video we'll be scanning a rotor from a Mazda RX-7 engine with an EINSCAN Rigil. I'll be making a few of these videos leading up to a full review of the Rigil. You can see here that we're going to do a laser scan and we have the global markers selected, so we must scan them first. And to note, I'm connected to the Rigil wirelessly through the Hotspot function. The marker scan is complete, so now we need to optimize the markers, and then I'm going to save them to a file so I could use them for scanning the second side of the rotor. Now we're going to switch to scan the point cloud. Our resolution is set to 0.2 millimeters, 38 lines laser mode, reflective, and full brightness. We are not capturing any texture because you could only do that in standalone mode. We are waiting on a software update to do it through EXScan software. I'm going to start the preview mode now on the Rigil touchscreen. And now I'm going to start the actual scan. I have the data quality indicator on, so it will turn blue when there's sufficient data. I have sped up the scan here and in a few other parts of this video. It'll be specifically displayed on the screen so you know how fast it's sped up and how long the original scan took, or whatever process is shown in the video. Now I'm going to use the cutting tool to remove the turntable and all of the data below it. We're going to push the plane up 1 millimeter to cut into the scan slightly so we clean up these edges that are touching the turntable, and we'll delete the selected markers too. You don't really need to delete the markers, but I did. You will notice back there that some of the markers look like they're tilted. They are not. The table is flat, but there must be some kind of bug or something. I submitted this information to Shining 3D. Now we're going to delete this vertical column. It's time to optimize and generate the point cloud. Now you don't have to optimize, you could just generate the point cloud too, but for all my examples I'm just going to optimize. While we wait, I'm going to go ahead and flip the rotor around. Not sure why there's still a few markers on the cutting plane, so I'm just going to reopen it and delete the selected markers. Again, you don't have to do this, I just didn't know at the time. This scan looks good, so we're going to go ahead and create another project here and rename this. So we'll call this side the top, and now we're going to scan the bottom side. In scan settings, we're going to go ahead and open our marker file that we saved earlier and switch to the point cloud. I'm going to pick up the scanner now, start the preview, and also check for brightness. Sometimes it seems that the brightness doesn't sync between EXScan and the actual Rigil software. I didn't mention this before, but if you look at the bottom right hand of the screen, you can see the frame rate, the total frames, and the total points that it's collecting as you scan. As with last time, we're going to use the cutting plane again to get rid of the turntable and all the data below it. Now we're going to get rid of the vertical column. Now we're going to optimize and generate the point cloud. The point cloud looks good, so we're going to go ahead and align the top and bottom. We're going to try auto align here, but it's not going to work because there's a lot of symmetry involved in this rotor, so it just doesn't know the top versus the bottom. So we're going to pick a few points here with a manual alignment. I'm looking at the rotor visually to identify the top and bottom to see where they get positioned. Now that I have the top and bottom oriented correctly, I'm going to pick the same points. It doesn't have to be perfect because it will do some automatic alignment close to where I'm marking. The alignment looks great, so we're going to proceed to group them and then return back to our point cloud. It's time to mesh the model. We're going to go ahead and select the standard filter with standard smoothness, remove spikes, and nothing else. I would have liked to select none as the filter, which was in all previous versions of EXScan software, but they removed it. Hopefully they'll bring that back in a future update so you could see what it's like without any kind of smoothing. You could still mesh on the Rigil itself standalone, and it has none. The mesh looks good, so we'll go ahead and confirm it. So just a note here, it's now October 14th. The scan data you saw previously was on October the 8th. All I did was export the mesh to an STL, and today I just opened EXScan, went to post-processing, and then opened the STL. We just wanted to review this rotor a little bit further in detail and give you some context. So the side seal groove here is supposed to be 0.7 millimeters. The diameters of the corner seals are roughly 10.9 millimeters, and the depths are 7.9 millimeters. This is just to give a little context of how far in the holes that the cross laser mode gets into. So you can see here, these oil ring seals, I mean, it's missed a good amount of it. I mean, you could get in some, but what you'd really want to do is switch to the 7-line parallel laser mode, and then you could get in here. Same with the cavities. I mean, you could get into the cavity some, but you're just not going to get all of it at any case. Same for the corner seals and maybe the apex seal groove. I'm not sure if it would go all the way in or not. I mean, that's pretty deep. Probably not due to the diameter. These are 2 millimeters. So if we look at the gear side, the same thing goes. I mean, you could see it made it in all the corner seal holes, but in reality, you know, you'd want to get this very clean by doing the 7-line parallel mode. But I mean, overall it looks pretty good still. It's clean around the edges. I mean, you can make out the gear. You could reverse engineer that even with this data, but again, the 7-line parallel mode, you could clean this up a bunch. You can see the bearing. It got that pretty well, and I mean, that's at an angle, and we had that vertical column in it. Without the vertical column, this looks a little bit better, but I added that vertical column with markers to help with the top, because you can have less markers, but it takes longer to get sufficient data so for this to turn blue. So now if we look at the face, I mean, that looks great. You could see nicks and stuff, and you could see these grooves. This is normal for a rotor. And you could even see the dent here, so there's some detonation. And I think that you can see a little detonation there too. And detonation there. So, I mean, it picked this up well. I mean, overall, this looks great for 0.2 millimeters. You can see the little stamps in there. And I think this concludes our video. Thank you for watching.